Aralan National High School of DepEd Naga City Division present
Radyo Aralan sa Naga. Radyo Aralan sa Naga.
Welcome Junior High School learners.
Radyo Aralan sa Naga.
Good afternoon my dear students in grade 9. I'm Salde Sombrero of Aralan National High School, your teacher in mathematics. Today, we will talk about how to illustrate quadratic inequalities in two variables. We are expecting that after this lesson, you can illustrate quadratic inequalities in two variables. Okay, shall we start? Get your notebook and a ball pen, and also make sure that you have your modules with you in Mathematics 9. Follow me as I discuss the topic. Okay? Let's start. As I mentioned a while ago, we are going to talk about illustrates quadratic inequalities in two variables. Before we continue, let us have this question. How do engineers and city planners plan and construct buildings to utilize the vacant lot to its maximum use? Is it involving mathematical concepts to solve those kinds of problems? Let's find out. Let us first define quadratic inequality. A quadratic inequality is a mathematical statement that relates a quadratic expression as either less than or greater than another. Again, a quadratic inequality is a mathematical statement that relates a quadratic expression as either less than or greater than another. Now, do you really understand what quadratic inequality is? Good to know that. One important skill to recall in order to easily understand this topic is illustrating quadratic inequality in one variable. Let's recall this first for us to have a smooth sailing as we learn a new skill. Let's have this inequality signs. Take a look at your module on page 1. Can you read this for me? That's right. The first one is A is greater than B. How about the second one? Yes, A is less than B. The third is A is greater than or equal to B. And the last one is A is less than or equal to B. Let's have a sample problem in quadratic inequality in one variable. The length of a garden is 3 meters more than twice its width and its area is greater than 36 square meters. To solve for this, we must represent the ano by a variable. Let W be the width of the garden and the length is 3 meters more than its width with the area of 36 square meters. The formula for the area equals LW. For you to understand better, kindly look at the table on page 2 of your module. It says that the area is equal to the length times width. We will use this formula to obtain the quadratic inequality of the given problem. By substitution, we have area is 36 square meter, which is equal to the length W plus 3m times the width. To simplify, we multiply the value of the length and width, and we have W plus 3 times W, which is equal to W squared plus 3W. That's why we will have 36 equals W squared plus 3W as the quadratic inequality in one variable. Quadratic inequality is an inequality that contains a polynomial of degree 2 and can be in any of the following forms. And variable is a letter or symbol used to represent a value. And now, you're ready to apply the skill again. Let's do this. Use the mathematical sentences found in Try This on page 2 to answer our activity. Determine whether the given is a quadratic inequality or not in one variable. Again, determine whether the given is a quadratic inequality or not in one variable. Are you ready? Let's start with number 1. X squared plus 4x is less than or equal to 9. Again, x squared plus 4x is less than or equal to 9. That is quadratic inequality in one variable. Number 2. X squared is less than 4x minus 5. Again, x squared is less than 4x minus 5. That is quadratic inequality in one variable. Number 3. X squared plus 5x minus 5 is less than 6. Again, x squared plus 5x minus 5 is less than 6. That is quadratic inequality in one variable. Number 4. X squared minus 4x plus 4 is greater than or equal to 0. Again, x squared minus 4x plus 4 is greater than or equal to 0. That is quadratic inequality in one variable. Number 5. Y is less than x squared plus 3x plus 2. Again, y is less than x squared plus 3x plus 2. That is not quadratic inequality in one variable. Number 6. Y is greater than 2x squared minus 5x plus 1. Again, y is greater than 2x squared minus 5x plus 1. That is not quadratic inequality in one variable. Number 7. Y plus 9 is greater than or equal to negative 4x squared. Again, y plus 9 is greater than or equal to negative 4x squared. That is not quadratic inequality in one variable. Number 8. Y minus 7x is less than or equal to 2x squared. Again, y minus 7x is less than or equal to 2x squared. That is not quadratic inequality in one variable. It's easy, right? What do you call those which are not quadratic inequality in one variable? That's right, they are quadratic inequalities in two variables. How do you differentiate those two kinds of quadratic inequalities? Absolutely correct. Quadratic inequalities in one variable are those with only one variable, while not quadratic inequalities in one variable are those with two variables. Now let's plan and construct. Turn your module on page 3. Let us illustrate this problem into mathematical sentence. The city government is planning to construct a new children's playground. It wants to fence in a rectangular ground using one of the walls of a building. The length of the new playground is 15 meters longer than its width, and its area is greater than the old playground. Let's have the solution. In the given situation, the width of the room can be represented by W and the length by W plus 15. Let the area of the old playground as A. Then the quadratic inequality that would represent the given situation is A less than W times the quantity of W plus 15, or A is less than w squared plus 15w. These are examples of quadratic inequality in two variables. What will be the possible area of a new playground? How many possible areas of a new playground that can be true to the quadratic inequality given? You can try to solve this in your free time. Let's now explore the world of quadratic inequalities in two variables. Turn your module on page 4. Look at the quadratic inequalities. This can be written in the form of two variables. These inequalities can be written in any of the following forms. Y is greater than ax squared plus bx plus c, or y is less than ax squared plus bx plus c, or y is greater than or equal to ax squared plus bx plus c, or y is less than or equal to ax squared plus bx plus c, where a, b, and c are real numbers, and a is not equal to 0. Let us study the following examples of quadratic inequalities in two variables. You can find this on page 4 of your module. Y is greater than x squared plus 2x minus 4 is in the form of y is greater than ax squared plus bx plus c, where a is equal to 1, b is equal to 2, and c is equal to negative 4. Another, y is less than 2x squared plus 1. Again, y is less than 2x squared plus 1 is in the form of y is less than ax squared plus bx plus c, where a is equal to 2, b is equal to 0, and c is equal to 1. Next, y is greater than or equal to 1/2 a squared plus 2a minus 4 is in the form of y is greater than or equal to ax squared plus bx plus c. Again, y is greater than or equal to 1/2 a squared plus 2a minus 4 is in the form of y is greater than or equal to ax squared plus bx plus c, where a is equal to 1/2, b is equal to 2, c is equal to negative 4. Last one is y is less than or equal to 2/3 x squared plus x is in the form of y is less than or equal to ax squared plus bx plus c, where a is equal to 2/3, b is equal to 1, and c is equal to 0. Now you are ready for the next activity. Let's do this. Open your module on page 5. Change quadratic inequalities in two variables in any of the form presented. Again, change quadratic inequalities in two variables in any of the form presented. Are you ready? Let's start with number 1. Number 1 is y is less than x squared plus 3x plus 2. The answer is y is less than x squared plus 3x plus 2. Number 2. Y is greater than 2x squared minus 5x plus 1. Again, y is greater than 2x squared minus 5x plus 1. The answer is y is greater than 2x squared minus 5x plus 1. Number 3. Y plus 9 is greater than or equal to negative 4x squared. Again, y plus 9 is greater than or equal to negative 4x squared. The answer is y is greater than or equal to negative 4x squared minus 9. Number 4, the last number. Y minus 7x is less than or equal to 2x squared. Again, y minus 7x is less than or equal to 2x squared? The answer is y is less than or equal to 2x squared plus 7x. Good job in finishing the activity. Now take time to process the information we acquired by accomplishing the next task. It's time to be a detective. Our goal in this section is to apply the key concepts of quadratic inequalities in two variables. We will use the mathematical ideas and examples presented in the preceding section to answer the activities provided. Here are the directions. Given the illustration found on page 5 of your module, choose the correct quadratic inequality that would represent the situation. Explain why. Note that A is equal to area of the pool, in which borders are not included. The length of the pool is 3W plus 10, while the width is W plus 5. Again, the length of the pool is 3W plus 10, while the width is W plus 5. Using the formula in finding the area of a rectangle, we will have area equals length times width, or A equals LW. Substituting the value, we will have A equals the quantity of 3W plus 10 times the quantity of W plus 5. Again, area equals the quantity of 3W plus 10 times the quantity of W plus 5. Simplifying the expression, we will have A is equal to 3W squared plus 25W plus 50. Since the border is not included, therefore, the area must be lesser than the area to be computed. With that, we will use the symbol less than. From the list of the options listed on page 5, we choose A is less than 3W squared plus 25W plus 50 as our answer. Again, we choose A is less than 3W squared plus 25W plus 50 as our answer. Let's do the second activity. Please turn your module on page 6. Suppose the length of the border of the pool is twice as its width. What would be the quadratic inequality that represents the situation? What will be the correct illustration? Using the formula in finding the area of a rectangle, we will have area equals length times width, or A equals LW. Since the length of the border of the pool is twice as its width, we come up with area equals the quantity of 2W times W plus 5. Therefore, the correct illustration is the second illustration found on page 6 of your module. It's easy, right? Did you enjoy the learning activities? I hope you did. To end this lesson, let's have the summary. To illustrate quadratic inequalities, we use the symbols less than, greater than, less than or equal to, or greater than or equal to. It's very helpful also to use formula to immediately find the right illustration of the problem given. That's it! We have finished the first part of this module. If you have queries regarding our lesson, our host will help you for the recap of what we have discussed. Now, it's time for you to answer the next task to enhance your understanding about illustrating quadratic inequalities in two variables. Go, go, go! You can do it! Once again, this has been radio teacher Salvi Sombrero from Cararaya National High School, Division of Naga, saying, stay safe and always remember, God is always there to protect and help us in times like this. Thank you, good afternoon, and God bless.
Radyo Aralan sa Naga. Radyo Aralan sa Naga. Radyo Aralan sa Naga.